Hey everybody, this is our second video for Unit 8. In the last video we talked about simplifying, multiplying, and dividing rational expressions. Today we're going to focus on adding and subtracting, which is actually a little harder because remember, when you're adding and subtracting fractions, you have to get a common denominator, which is going to be a little more challenging. We're going to have to do a little bit more work to be able to get a common denominator. Once we get a common denominator, remember with fractions, we add the numerators together, we keep that common denominator the same, and then we're going to simplify like we did in the last video. Factor, cancel out common factors, and go from there. So let's look at our first example here. Okay, right off the bat, you can see, hey, we already have common denominators, which is really convenient. If I want to add these fractions together, I'm going to keep that common denominator that we already have, and I'm going to combine the numerators together. So if I'm adding the numerators, I'm combining like terms. We're going to get y squared plus 10y plus 21. So now we have a single rational expression, and we can just focus on factoring and simplifying. So in the numerator, I can factor that into y plus 3 times y plus 7. And then in the denominator, I have a difference of squares that will factor into y plus 3 times y minus 3. So now we can see there is a common binomial of y plus 3 in the numerator denominator. We cancel them out. We are left with y plus 7 over y minus 3. But most of the time, we're not going to start with a common denominator, unfortunately. Sometimes, when you start off with something like this example, the best way to find your common denominator is to factor the denominators that you have to see if they start with even something in common. So what I mean by that is, if we look at this denominator here, I can factor out a GCF of 5, which is going to reveal a k minus 2 left over, which matches what we have here. So the denominators at least have a k minus 2 in common, which is nice. That means that in order to get a common denominator, we really just need to multiply this expression on the right by 5 over 5. Okay, if I do that, that's going to give me my common denominator of 5 times k minus 2. Okay, so let's do that. Okay, our first rational expression, we're not doing anything to it. I'm going to keep the denominator in that factored form because we're going to eventually factor at some point anyway. So no point to multiply things back together. So after I multiply by 5, we've got that common denominator, so we can actually subtract these fractions, these rational expressions now. Remember, the numerator will actually subtract, so k squared plus 16 minus 20 would give us k squared minus 4. And then we still have that 5 times k minus 2 in the denominator. Now, the numerator can factor some more. It's a difference of squares. So I'm going to factor that. And we see that there is a common binomial of k minus 2 that can be canceled out. So our final expression here is going to be k plus 2 over 5. Let's look at one more example where it's a little trickier to get that common denominator. Just looking at the denominator in each expression here, it doesn't look like there's going to be anything in common, but like we did last time, let's just try factoring each one of these to see, what the factors are, to see if, maybe at least one piece matches. So in the first one here, we can factor out a 4, which leaves us with a p minus 5. And then in the second expression, this would factor into p minus 3 times p minus 5. So they at least have something in common. They have this factor of p minus 5 in common. That means we need to multiply the expression on the left by the p minus 3 and the expression on the right by a 4. Okay, so our common denominator altogether is going to be 4 times p minus 5 times p minus 3. All of those things together will make up that common denominator. And this is where it really is kind of challenging. Make sure you're keeping yourself nice and organized. Make sure you're not forgetting any factors. It can get a little messy, so give yourself a good amount of room to work here. Okay, so we said the expression on the left needs multiplied by that factor of p minus 3. So we have 2 times p minus 3, right? I'm multiplying my numerator by that. And the denominator, we already had 4 times p minus 5. We have to multiply the denominator by p minus 3 as well. Okay, so that's our first expression. Okay, and then the expression on the right we said need multiplied by 4 over 4. So that's going to be 4 times p minus 6, which was already there. And we have that denominator of 4 times p minus 5 times p minus 3. Okay, so now let's actually add. We have 2p minus 3, or 2 times p minus 3, plus 4 times p minus 6. We are going to have to multiply that stuff back together so that we can combine like terms and then refactor. Right now, if I just leave my numerator as this, I won't be able to actually cancel out any common binomials or common factors because in the numerator there, we have addition between terms. Okay, that plus sign right there makes it so that we are not allowed to cancel out the p minus 3, that common binomial that you see right now. Okay, you have to make sure before you start canceling out binomials or factors of any sort that the numerator is a bunch of factors that are being multiplied together, and same with the denominator. You can't have any addition or subtraction between like groupings like this. So we have to distribute and recombine our terms. So we have 2p minus 6 plus 4p minus 24. Remember, we want to leave the denominator untouched because it's already factored. Okay, let's combine like terms in the numerator. So we get 6p minus 30 we can factor out a GCF of 6 in the numerator. And there's a couple things we can do. Okay, first of all, we can now cancel out this common binomial of p minus 5. We can also reduce 6/4 to 3/2. So our final expression is going to be 3 over 2 times p minus 3. All right, seriously, give yourself a lot of room when you're doing these problems. Write out a lot of steps. I know it's kind of a pain to write things over and over and over, but if you try to do too many steps at once, you're going to start making mistakes. So give yourself room, keep yourself organized, and have a wonderful rest of your day.